Okay, this is warm-up video 10-9 or 10-10, depending on what period you are, knowing the kind of math you need to know for the quarter one benchmark. So here we go. This first problem, counting number of white squares. So if I look, this one starts with 3, and then I go up to 5, and then up to 7. What I'm trying to show you there, that this is going up clearly by 2, clearly by 2. I'm looking for all the numbers that have that clear 2, that common difference, that rate of change, that slope in the right place. If I look, this one has 2 in the right place for recursive. This one has 2 right in front of x using that first term. And then this guy has 2 in front of x using that 0 term, knowing that if I went back to the design 0 and subtracted 2 from this 3 right here, it would give me this 1 right here. That's where I got that 1. It didn't come out of thin air. It was a reason where that 1 came from. And then knowing that this one is the only one that has no 2 in the right place, has a 3 right there, makes that one jacked up. Even though there's a 2 right there, don't be fooled. That 3 in front of x makes that one bad. And then knowing that I have a good equation now, taking 51 and plugging into this spot right here. So to find 51, I plug in 2, and where that x is, that's where I plug in 51. I'm going to times that, and I'm going to add that to 1. That will give me what f of 51 is, or when I plug in x is 51. So if I use my calculator, 2 times 51 gives me 102, and then if I add that 1, will tell me that at the 51st step for this pattern, I would have 103 white squares following this pattern. All right, next one. Knowing that the number in front of x, this is the rate of change number, this is the slope, this is the d number, this is the number that keeps adding each time. I keep adding 250, adding 250. That is the slope. This number right here by itself is the y-intercept. That is the y-intercept. So if I look, the only one that has that number, the y-intercept, which is $200, is this one right here. This is the one. That is the deposit fee. Not the $250 deposit fee. That's the rent. Not $250. Even though this is key, I'm not asking for that. I'm asking for the deposit. So the y-intercept, that's not right. And then this one, that $200 a month, that is not right. $200, that is the deposit fee. All right, here we go. Next, looking at these, any problem that has a percent in it is one of these geometric curve graphs. So if I look, this one clearly has a percent in there. So number 1 is going to go right there. The other one with a percent, oh, no others. So no other exponentials. Nope, don't put that in linear. Put that one in exponential. So that would be right here. All right, moving on. Other ones that don't have a percent. This one increasing by just 1/5 is just adding 1/5. That one makes number 2 linear. That's going to be linear number 2. If I look at the next one here, I got 5 and adding just 20. Let's go to number 3, adding 20. Just adding 20 each year makes number 3 clearly linear. Number 3 is linear. Number 4, I got 5, 8, 13. If I look, 5 to 8 going up by 3. 8 to 13, though, going up by 5. That makes this one neither. If this was going up by 3, then I would have put this into linear, but it's not going up by 3. All right, here we go. Next one. Got to do a little bit of math. Taking $36 and dividing it by 2 hours to see. So 36 divided by 2 gives me $18 for every 1 hour. And then I'd look at this next little batch and divide $57 by 3 hours. So 57 divided by 3 gives me $19 per hour. Since they are not the same, It's not linear. I'm going to put number 5 in the neither. If that was the same, I would put it into the linear. All right, here we go. Next one's this one. If I take these two numbers and I subtract them on my calculator, I'm talking just taking 54 minus 37. That will give me the number that I'm adding each time for these. Adding 17, clearly plussing 17, plussing 17, plussing 17. That makes this arithmetic going to be a straight line. For recursive, here's recursive. Recursive is f of x equals f of x minus 1, and I add that blue 17 right there. For explicit, I'm going to go backwards and take away 17 from this negative 54. So if I do negative 54 minus 17, that gives me the y-intercept term, which is negative 71. That's the number I'm going to use with this slope number right here to write that equation. So here I go. This equation is that 17 in front of x minus that 71 right there. That is explicit form. First one is recursive. All right, here we go. Take these two numbers and divide them. You'll see what I'm dividing on this problem. So if I divide that, that gives me 2. Remember, I'm dividing by 2. But remember again, we don't show dividing by 2. We show as timesing by 1/2. That means this is definitely geometric. That means if I was to write the recursive form, it would be f of x minus 1 times that 1/2 right there. If I was to go backwards, timesing by 2, the whole number, what I'm timesing by 2 is this 96. So 96 times 2 gives me 192, my y-intercept term. So if I was to write that equation with that number and my slope, that would be f of x equals that 192 times, no plussing in here, put that 1/2 and then raise that to the x power. That's going to be my explicit form for geometric. All right, next one. Looking at this, looks like I got one right away. This one timesing by 2, timesing by 2, timesing by 2. That makes this one exponential. It's going to be one of these curvy ones. None of these other ones are exponential. This is going up by 1. This is going up by 4. It's neither. This is going up by 1, then going up by 2, and then going up by 3. That's neither. This is going up by 2, going up by 2, going up by 2. That's a linear one, but I'm not asking for linear. I'm asking for exponential. All right, almost done. Take these two numbers and divide them. Take 416.16 and divide it by 408. That will give me the number I'm dividing by. So 416.16 divided by 408 gives me 1.02. That's my ratio number. That's the number that I'm timesing each one to get from one number to the next. Let's get rid of this thing right here. So for this guy, I'm timesing by 0.02. That's my ratio number, which means going up this column, I'm dividing by 1.02 to find this 0 number. And what I'm dividing by 1.02 is this 408. So I take 408 and divide it by 1.02, and that will give me the y-intercept number, which is 400. That's this number right here. If I was to write this equation, where this is x and this is kind of y, my equation would be f of x, though, using function notation, that 400 times in parentheses that 1.02, and then that whole thing raised to the x power. Don't forget that x power in there. You can't forget that. That would be wrong if you didn't put it in there. All right, last one. This guy looks like I'm timesing by, let's see, 36 divided by 12. Looks like I'm timesing by 3. Timesing by 3. So going this way, dividing by 3. And what am I dividing by 3? This 12 right here. So that 12 divided by 3 gives me 4. That is my y-intercept term, 4 right there. If I was to write this explicit, it would be f of x equals that 4, which is the number before 12, times that 3 number, the number I'm timesing to the right, all raised to that x power. That would be this one right here. And again, remember, 12 divided by 3 is 4. Or if I take 12 times 1/3, if you remember how to times fractions, that gives me 12 over 3, which is that same 4. That's how we're getting that 4. All right, hopefully there's no mistakes this time. Hopefully this helps. Good luck.